Hi, I'm going to explain about the 3 examples from 4.6 and 3 examples from 6.2 and 3 examples from 7.2. First, we're looking for a collinear tank. First, before we start, the volume of the collinear tank is 1/3 pi r square h. A collinear tank at the rate of 9 feet cubic minute is telling that dv over dt is 9 feet cubic minute. We also know the height of the tank is 10 feet and a base radius of the tank is 5 feet. We need to find the water level rising, which is dH over dt. When the water is 6 feet deep. So we know radius is 5 feet and height is 10 feet. So we can say that r over h is 5/10, which means 1/2. So when you multiply h on both sides, we'll get r is equal to h over 2. And then when we substitute this into the volume equation, we will get v is equal to 1/3 pi times h over 2 squared times h. When we simplify this, we will get v volume equals to pi over 3 h squared over 4 times h, which is pi over 12 h cubic. And then when we perform implicit differentiation on the volume equation, we will get dv over dt is equal to pi over 12 times 3h squared times dh over dt. We know that dv over dt is 9 and h is 6. When we plug this into the implicit equation, volume equation, we'll get 9 is equal to pi over 12 times 3 times 6 squared times dh over dt. When we simplify this, we'll get 9 equals to 9 pi dh dt. When we divide by 9 of both sides and divide by pi on both sides, we'll get 1/pi is equal to dh over dt. So since dh over dt is 1/pi, when h is 6 feet, we can say that the water is rising at the rate of 1/pi feet over mean when the water is 6 feet high. And then let's move on to next question, the high h's. So for this question requires a lot of thinking about the direction. This is because it can be negative or positive depending on the direction. The car is 0.8 miles to the east and the cruiser is 0.6 miles north. So I will draw the direction. For the cruiser, first the car is moving 0.8 miles to the east. We will call this h. And the cruiser is going to 0.6 mile, and this is going to be z. And we'll call the distance between the car and cruiser will be W, which will be 1, and they are increasing at 20 meters per hour. And this will be W over dt because of the distance over time. So it will be positive speed. The cruiser is moving at 60 meters per hour at the instance of measurement, so this is going to be calculated as negative. So dz over dt will be negative 60 meters per hour. So to solve this problem, we need to use Pythagorean theorem, yes, which is a squared plus b squared is c squared, and then we multiply d over dt on both sides, and then plug in the numbers. We'll get 2z dz over dt plus 2h dh over dt is equal to 2w dw over dt. When we plug the numbers on this in those, we will get 2 times 0.6 times negative 60 plus 2 times 0.8 times dh over dt, which we have to find it. And then 2 times 1 times 20. When we simplify this, we get negative 72 plus 1.6 dh over dt is equal to 40. When we simplify this, we'll get dh over dt is equal to 70 meters per hour. And then the next example, the hardest one. So before solving a problem, it is important to read the problem first and then draw the information given in the problem first. In the case of this type of problem, it is more efficient to draw a picture and clearly graph the information given in the problem and then solve it, rather than just writing numbers and solving the problems. Let's start. The first thing to check is to check the variables given in the problem, and it is important to know what kind of relationship the variable have. In this problem, we must check what variable we are supposed to use. The problem gives us the distance between a hot air balloon and the rangefinder, and it also gives us hot air balloon increasing at a rate. We have to find how fast the volume is rising at that moment. We should use d over dt times tangent zeta is equal to d over dt times h over d is equal to d over 500. I will show you with the drawing. So this is rangefinder, and this is going to be air balloon, hot air balloon, and this distance will be 500 feet. And then the angle, the zeta, will be pi over 4. And this is going to be h, and we need to find the h over dt. And we can know that the theta over dt is 0.14 radian per minute. So I said before, we have to use d over dt tangent zeta is equal to d over dt h over d, which is h over 500. Range derivative, tangent zeta derivative is secant squared zeta d zeta over d tan dt, which is equal to 1 over 500 dh over dt. Second, we can know that cosine of pi over 4 is equal to root 2 over 2. Secant pi over 4 is, we can know that it is the opposite, which is 2 over root 2. So secant square of pi over 2, pi over 4 is just 2. So secant square is 2. And then we know d theta over dt is 0.14, which is equal to 1 over 500 times dh over dt. When we calculate this and simplify this, we will get 140 feet per minute is equal to dh over dt. This was 4.6 examples. Next is